Hello everyone. In this video, we're going to talk about how to solve and graph linear inequalities. The process is going to be the same. Our goal is going to be to isolate x, or whatever variable we're using. I'll just say isolate variable. So the process is the same. Um, we're going to think about that inequality. And when we talk about inequality, we're going to see these signs or we're going to see these signs. So we have less than, and then we have less than or equal to, and then we have greater than, and then we have greater than or equal to. So we're going to treat that inequality like a wall. Okay. The only difference with that wall, we're still going to do the same thing on both sides, but the only difference happens when we divide or multiply by a negative. When you divide or multiply by a negative, you must flip the inequality sign. So if it's going this way, so if it's a greater than, you're going to flip it to go less than. Okay, let me explain the why. Let's say we have something simple like x is less than 3. And then let's say we have negative x is greater than negative 3. Okay, these actually mean the same thing. X is less than 3 is looking at all values less than 3. If I were to think about this guy and just kind of rearranging it, I could move this x over and then I could move that 3 over. So I can think about it that way. So if I do that, I'm going to add x to both sides. Negative x plus x is 0. So I have negative 3 plus x. Now I could add the 3 to both sides. So I'm going to get 3 is greater than x. And if you were to flip that so that the variable is on the left, like this first one, notice that is pointing, the inequality is pointing towards the x. Well, it would have to point towards the x this way too. So I would end up with the same inequality that I started with. Now I could also get there by using division. I have negative x is greater than negative 3. Let's divide everything by negative 1. So I'm going to have x here, negative 3 divided by negative 1 is a positive 3. And then because I divided by a negative, I have to flip the inequality. You can see how that's going to give me the same answer as what I had before. So these are all equivalent statements. Okay, but the only way they're equivalent is because of the rules of algebra and that flipping the inequality when I divide or multiply by a negative. So that's the only extra thing we need to remember. So we're going to start with graphing on a number line. If we have a less than or a greater than sign, strictly less than or strictly greater than, we're going to use an open circle to graph. If we have an equal to, like less than or equal to or greater than or equal to, we're going to use a closed circle to graph. Now, some textbooks won't use the open and closed circles. They will use a parentheses. If it's not including a value, so strictly less than or greater than, and then we use a bracket if it's including, so greater than or equal to or less than or equal to. So let's look at number 4. We have x is less than negative 4. Variable is on the left. Here's negative 4. This is going to be an open circle, and I want everything less than negative 4, which is going to be everything to the left of negative 4. So I just would shade it that way. Okay, some books won't use the open circle. They'll just use a parenthesis, so it would look like this. Same kind of thing, only a parentheses at the -4 instead. If the variable is on the left, the inequality will always point in the direction you need to shade. Okay. If it's on the right, then you just would rearrange it so that it's on the left. So let's look at example 2. We have x is greater than or equal to 3. So greater than or equal to means we're going to use a solid dot. And then we are looking for values bigger than. That's what greater than means, or equal to. So we're going to shade everything to the right. Notice I'm shading in the direction of the inequality sign. Okay, some textbooks use brackets because we're including, so it would just look the same way, just a bracket instead of that circle. Example 3 is an in-between. We have -2 is less than or equal to 7. Is less than or equal to x, which is less than 7. -2 is going to have a closed circle. 7 is going to have an open circle. And x is between those, so I am shading in between. Okay, some textbooks would use a bracket on the -2 and a parentheses on the 7, and then shade in between. This is where you may want to pause the video, try the next two, come back and check the answer. So we're looking at x is greater than 5. We're going to use open circle, and we're going to shade it to the right. In B, we're looking at -6 is less than x is less than or equal to 1. -6 will be an open circle. 1 will be a closed circle. And we're going to shade in between because x is in between. Now we can write these in with inequalities, or we could use something called interval notation. So we're going to start with the graphs. So if we look at this first graph, we've got a closed circle at 2 and it's shaded to the right. And notice the arrow here is just going to keep going. So this guy's going to head to infinity. So if I'm thinking about inequality notation, I'm going to look at my value. I'm going to use the variable x. Because it's a closed circle, it's greater than or equal to, and I'm looking at everything bigger than 2. So I would say x is greater than or equal to 2. Interval notation is going to use parentheses and brackets. So because I have a closed circle at 2, that's where this graph is starting. So I'm going to use a bracket on 2, and this guy is heading towards infinity. So I'm going to use infinity. Here on the right-hand side, infinity is always going to have a parentheses because we can never quite reach it. So I'm going to use bracket 2, comma, infinity, parentheses. There's my interval notation. Let's look at the next one. We have this graph that has an open circle at -3 and it's shaded to the left. So I'm looking at everything less than -3. So inequality would say x is less than -3. Strictly less than because of the open circle. Interval notation, let's think about that number line again. So this left-hand side heads to -infinity. So I'm going to use -infinity, comma, -3. And I'm using parentheses on the -infinity and the -3. Look at example 3. I have an open circle at -1, closed circle at 4, and it's shaded in between. So I'm looking at all x values between -1 and 4. Open circle at -1 means I'm using a less than. Closed circle at 4 means I'm using less than or equal to. So my inequality notation would look like -1 is less than x is less than or equal to 4. Interval notation on -1, we would have a parentheses. On 4, we would have a bracket. So we would have parentheses, -1, comma, 4 bracket. So this is where you may want to pause the video, come back and check your answers. So in this first one, we have a closed circle at -4 shaded to the left. So this graph heads off to negative infinity. Inequality notation is going to say all x values less than or equal to -4. Interval notation is going to be parentheses, negative infinity, comma, -4, and bracket because of the closed circle. B, we have an open circle at 5, and it's shaded to the right, and it's heading off to infinity. Inequality notation is going to say x is strictly greater than 5. Interval notation is going to go from parentheses 5 to comma infinity with a parentheses on infinity. So solving linear equations, like I said, it's going to work the exact same way. The only difference is if we happen to divide or multiply by a negative, we flip the inequality. So if I look at the first one, 2x plus 5 is greater than 13. The goal is to get the 2x term by itself first. So we're going to zero out by subtracting 5. So I'm going to do 2x is greater than 8. And then we're going to divide by that positive 2. And we're going to get x is greater than 4. So there's my interval notation. If I wanted to graph it, I like to put 0 on my graph. And then here's 4. Open circle, shaded to the right. And then if I want interval notation, I'll call it INT notation. It would be parentheses 4 to infinity, close parentheses. So inequality notation would be x is greater than 4. Interval notation would be 4 to infinity. And then we've got the graph down here, open circle at 4, shaded to the right. Next one, we have negative 3x plus 4 is less than or equal to 19. Goal is to get the x term by itself. So we're going to peel that first layer off. We're going to subtract 4. So I have negative 3x is less than or equal to 19 minus 4 is 15. And then we're going to divide by negative 3. And remember, when we divide by a negative, we flip the inequality. So we're going to get x is greater than or equal to negative 5. So there's my inequality notation. On the graph, I'm going to have a closed circle at negative 5, and we're shading to the right. Okay, remember this goes off to infinity, so you can see the interval notation coming out here. It's going to be bracket, negative 5, comma, infinity, parentheses. Let's look at example 3. We have 4x minus 7 is greater than or equal to 2x plus 9. So we got to get all the x's on one side, all the numbers on the other. So I'm going to start by subtracting 2x from both sides. That's going to zero out the 2x on the right. So now I have 2x minus 7 is greater than or equal to 9. And then we're going to add 7 to both sides. So I have 2x is greater than or equal to 16. And then we're going to divide everything by 2. Since I'm dividing by a positive 2, I do not need to flip the inequality. So my inequality notation says x is greater than or equal to 8. On the graph, I'm going to have a closed circle at 8, and I'm shading it to the right. This thing heads off to infinity, so from the graph, we can see that we're going to have a bracket at 8, parentheses, and then infinity on the right. So this is where you may want to pause the video, try a couple, and come back and check your answers. In part A, we have 3x minus 2 is less than 10. We're going to start by adding 2 to both sides. So I have 3x is less than 12, and then we're going to divide by 3. I'm going to get x is less than 4. So inequality notation is x is less than 4. On the graph, I'm going to have an open circle at 4, and I'm shading it to the left. So my graph is going from negative infinity up to 4. So interval notation would be parentheses, negative infinity, comma 4, close parentheses. The next one, B, I have negative 2x plus 6 is greater than or equal to 14. I'm going to start by subtracting 6 from both sides. So now I have negative 2x is greater than or equal to 8. And then we're going to divide by negative 2. But don't forget, when we divide by negative, we have to flip the inequality. So I have an answer of x is less than or equal to negative 4. And what that means is any number less than or equal to negative 4 would satisfy that original statement. On my graph, negative 4 is going to have a closed circle, and I'm going to shade to the left. Interval notation, that left-hand side's heading off to negative infinity. So I'm going to have parentheses, negative infinity up to negative 4, and bracket on the negative 4. Compound inequalities are going to work the exact same way. With a compound inequality, I want to think about these as in-between problems. So the goal is to get x by itself, but we're going to think about the walls here. Okay, it's going to work the same way, only now what I do to the middle, I have to do to both sides because I'm going to have a wall at each inequality. So the first one, I have negative 2 is less than or equal to 3x plus 1, which is less than 4. Goal is to get x by itself in the middle. So I'm going to peel that first layer off and subtract 1. What I do to the middle, I got to do to the left and to the right. So I'm going to have negative 3 is less than or equal to 3x, which is less than or equal to 3. Oh, just kidding. Which is strictly less than 3. And then we're going to divide everything by 3. What I do to the middle, I got to do to the left and the right. Okay, I divided by positive 3, which means I do not flip any inequalities. So I'm going to get negative 1 is less than or equal to x, which is less than 1. So there's my inequality notation. On the graph, negative 1 is going to have a filled-in circle, closed circle. 1's going to have an open circle, and I'm shading in between the two numbers. Interval notation will go from bracket negative 1 to 1 with parentheses. Okay, the next one's going to work the same way. We have negative 5 is less than 2x minus 1, which is less than or equal to 9. Starting in the middle, we're going to add 1 in the middle, which means I'm going to add it to the left and to the right. So I'm going to have negative 4 is less than 2x, is less than or equal to 10. And then we're going to divide everything by 2. So I'm going to get negative 2 is less than x is less than or equal to 5. So there's my inequality notation. I'm going to do the graph next. Negative 2 has an open circle, 5 is closed, and we're shading in between. Interval notation is going to be parentheses, negative 2, comma 5, bracket. And then let's look at example 3. Same concept. We have 7 is less than negative 2x plus 3, which is less than or equal to 15. Working inside out, so I'm going to subtract 3 from all sides. That's going to zero that 3 out in the middle. So I'm going to have 4 is less than negative 2x is less than or equal to 12. And then we're going to divide everything by negative 2. But remember, you got to be careful. When you divide by a negative, you have to flip the inequality, and you do have to flip all of them. So I'm going to get negative 2 is greater than x, which is greater than negative 6. Okay, I don't like reading things that way. I'm going to flip the whole thing. So notice that my negative 6, that point is pointing towards it. And then notice my point is pointing towards the x here. So that's equivalent to negative 6 is less than or equal to x, which is less than negative 2. So inequality notation is -6 is less than or equal to x, which is less than -2. My graph is going to have a closed circle at -6, open circle at -2, shaded in between. Interval notation, bracket, -6, comma, 2, parentheses. Okay, when you look at compound inequalities, I want you to notice something. The arrows always point the same way. The inequalities always point the same way every single time. They cannot point opposite ways. So we cannot write something like this. -1 is less than x and greater than 3. Okay, keep that in mind. The arrows have to point the same way. The inequalities have to point the same way. Okay, let's do a couple, try it on your own. So this is where you may want to pause the video, come back and check your answer. We have -1 is less than or equal to 4x minus 3, which is less than 9. We're going to start by adding 3 to all sides. So we're going to have a 4x in the middle. We're going to have 2 on the left and 12 on the right. So we have 2 is less than or equal to 4x, which is less than 12. And then we're going to divide everything by 4. So we're going to have 1/2. I'm going to reduce that 2 over 4 there. It's less than or equal to x, which is less than 3. So there's my interval notation. 1/2 is going to have a closed circle. 3 is going to be open, and we are shading between. Interval notation is going to have a bracket, 1/2, parenthesis, comma, 3, and then parentheses on the 3. B, we have -10 is less than -3x plus 2, which is less than or equal to 5. We're going to start by subtracting 2 from all sides. So in the middle and then the left and the right. We have -12 is less than -3x, which is less than or equal to 3. And then we're going to divide by -3. But what happens when we divide by negative? We're going to flip that inequality. And we're going to have to flip all the inequalities. So I get 4 is greater than x, is greater than or equal to -1. I don't like reading it that way. I like my smallest number to be first. So notice it's pointing towards the -1, so that less than or equal to has to point to the -1 when I flip it. You could literally think about writing this on a piece of paper and then flipping that piece of paper over, and you'll see how everything just kind of flips. So I have -1 is less than or equal to x, which is less than 4. Graph, -1 is going to be a closed circle. 4 is going to be an open circle, shade in between. Interval notation is going to go bracket -1 to 4 with parentheses.